This is yet another system of equations question on this test. It's still like there's a lot of them, but this one is different because it has a parabola. And so the overall process for systems is always the same. We want to get rid of one of the variables, right? So we have two equations, usually with two variables each. And that's bad. When we have two variables, we're kind of stuck in algebra. There's not much we can do. But if we have one variable, we can solve. So our goal really is to take these two equations and smush them together in such a way that one of the variables goes away. And in this case, it's actually really easy to do because the second equation is just like y equals a number. So we can easily substitute that number in for y in the first equation. And so we get something that is pretty easy to work with. Now, it kills me, this question, because the normal thing we're supposed to do when we have quadratics is move everything around and simplify it in whatever way we can, but our goal usually is to get 0 is equal to whatever. That's our usual goal. Now in this case, that causes a problem. I'll show you what happens at the end. The most efficient thing to do at this point is probably what most of you would do, which is get rid of that squared. Take the square root of both sides and get rid of it. And when you do that, you end up with 5 is equal to x minus 11. And then you just do the reasonable thing. You add 11 to both sides, and you get that x is equal to 16. Now that's an answer, but that's a trap, because that's not what they want. We have to look at the question again. They say that it's intersecting at 2 points. We just found one. Now, we have to think, well, why would there be 2 points? What could possibly cause that to happen? Well, it's because we took the square root instead of doing what I said at the beginning and solving for 0 equals the equation. So when you do this square root thing, you have to recognize that there are two square roots of 25. There's 5, and then there's negative 5. So we need to produce a parallel equation that has a negative where the square root goes away. So that's annoying. It's just not something we're used to, and so we're going to add 11 like we did before, but now we get a different number. Now we get that 6 is equal to x. And there are our points. So just to be clear, the 2 points that we have for this equation are 1625 and 625. And I know the y-coordinate because that's what they told me originally. The y-coordinate has to be 25. That was just the rules. And now the distance, the length of that line is 10. It's really easy to figure out, right? 16 minus 6 is 10. And that's choice A, and that's the answer. So that's probably the most efficient way to do this. The reason it really kills me, though, is I know that many of us are going to forget to do that plus or minus 5 thing. And that's really the key to the question. And so my general advice for pretty much every other situation is don't do those square roots. Just remember that when you have a quadratic, you really want to get it into a place where you can like have 0 equals the equation and then factor that equation. Now if we did that, let's go back to here. We'd have 25 is equal to x minus 11 squared, and we need to distribute that 2, but we can't just distribute it, we have to FOIL. So this really is x minus 11, and foiling that out gets us x squared minus 22x plus 121. So these are now starting to get some big numbers, and without a calculator, many of us aren't confident with those numbers. So now we take over and say, oh, I want to get that 25 over to this side, because 0 being alone for a quadratic is really good. But we still have a messy thing. X squared minus 22x plus 96. And so like, I have to factor 96. It's such a messy number because it's big, but more importantly, it's got a million factors. It's a number that a lot of numbers divide into. And so this could take some time. I don't know off the top of my head all the factors of 96. And so the process hasn't changed. It's just a huge pain in the neck. I'll just skip to the end here. It ends up being that negative 16 and negative 6 multiply to 96 and add to negative 22. Okay, so those are our numbers, and then if we solved those, we would get that x is equal to 16 and x is equal to 6, which is exactly what we got before. So I doubt that that's going to be more efficient for most of us, but I wanted to show it to you because I think that in most cases on the SAT, and I guess and in real math too, when you have a quadratic or a squared somewhere in your equation, it's best to move everything over to the other side and have a 0 and then factor that result, because what factoring does is it guarantees that if there are multiple answers, multiple solutions, we see them all. This move that we did with the square rooting, like it sometimes works, but we kind of need to remember that there's a plus or minus, and I think that's just hard for us to do. So I'd rather us memorize one process than several. And so to me, this right here is the one process we should memorize. I'm sorry. I wish I could be more certain about things, but this is just a really annoying situation, and we've got to take a weird route to get there, but hopefully you can get it some way or another. There's just a lot of confusing algebra, and it makes it a frustrating question.